In this particular example, we're given a cubic function. We're told that when we draw a tangent line to this particular curve at the point -4, 1, that this particular tangent line will intersect the curve at a second point, and we're asked to find the slope of the tangent line at that second point of intersection. This actually is one of my favorite questions, and you should spend some time understanding it. What I find that when kids learn the power rule, initially all they do is take the derivative and evaluate the derivative, and they forget what it represents. This is one of the few questions that I can ask that asks you to go beyond that and really test your knowledge of what we're doing with these particular questions. So what I'm going to start by doing is taking my graphics calculator and graphing this cubic function. And that's what I've done. I've put a little sketch. And then I've labeled the point -4, 1 on our graph. And using the green marker, I've drawn a tangent line to the curve at that point. What you'll notice is that that tangent line does indeed intersect the curve at a second spot. We need to find that other point, and then we need to draw a tangent line to the curve at that point and find the slope of that particular tangent line. So hopefully this diagram at least explains what we're trying to accomplish in this question. We ultimately want to find the slope of that second tangent line. So we start by finding the slope of the tangent line at our point -4, 1. So we take our derivative of our cubic function using our power rule, and we find that y prime is equal to -3x squared minus 18x minus 27. What we're going to do is substitute -4 in for x so that we can find the slope of the tangent line specifically at x equals -4. And when we do that, we find that the slope of the tangent line is equal to -3. Now, we don't just need the slope of that particular tangent line, we need the equation of that tangent line, because ultimately we have to find the point of intersection between this linear function, our tangent line, and our cubic function. So to find a point of intersection, we're probably going to be doing substitution, and we'll need the equations of both of those functions. So I say our tangent line is a linear function, so its equation will be of the form y equals mx plus b. We know what m is, the slope, we just worked it out. It's -3, so we now have y is equal to -3x plus b. We need to find the y-intercept for this function. Now we do know that this linear function passes through the point -4, 1. So we can use that x and y value to help us find our b, y-intercept. So I do that, and I find that b is equal to -11. So we can conclude that the equation of our tangent line is y equals -3x minus 11. Now what we have to do is say, how do we find the point of intersection between this tangent line, or linear function, and our cubic function? Well, in this case, I'm going to do substitution. Some people would say, oh, I make the equations equal to each other. But remember that it's really called substitution. We're substituting in for the y's. So I end up with -3x minus 11 equals -x cubed minus 9x squared minus 27x minus 27. I'm going to take this cubic equation and set the whole thing equal to 0. So I end up with x cubed plus 9x squared plus 24x plus 16 is equal to 0. Now, in this form, we can't use factoring by grouping to solve for x. We're probably going to have to use the rational root theorem. But what's fortunate is that we already really know one of the points of intersection. We already know that this linear function, or tangent line, intersects our cubic function at x equals -4. So we actually know one of the roots for this equation. So that saves us the hassle of using the rational root theorem. Now I'm going to use synthetic division to find out what this cubic expression factors down to. Some of you may choose to do long division. That's up to you. So I put my value, my root, -4, up in the corner. I lay out all my coefficients for my cubics, which are 1, 9, 24, and then finally the constant 16. And then I do my synthetic division. and I find what I end up with in my bottom row is 1, 5, 4, and 0. The 0 represents the remainder, which it should, because we do know that x equals negative 4 is indeed a root of this particular cubic, so the remainder has got to be equal to 0. And that tells us that if one of our factors is x plus 4, then our other factor, the 1, 5, and 4, that tells us that that other factor has got to be an x squared plus 5x plus 4. So now I can take that quadratic and factor it further, so I end up that my cubic function factors down to x plus 4 times x plus 4 times x plus 1, and they're all equal to 0. So that means either x equals negative 4, no big surprise there, we already anticipated that, and x equals negative 1. That's the value we're interested in. That's where the tangent line intersects the curve at a second spot. It occurs at x equals negative 1. And if you think back at our original diagram, that looks like it's a reasonable answer. Now all I have to do is find the slope of the tangent line at that second point. So I say I take my derivative, y prime is equal to negative 3x squared minus 18x minus 27, and I substitute in my value of x, which is negative 1, and I find that the slope of the tangent line at x equals negative 1 is negative 12. And again, if you go back and look at our original crude sketch, that slope seems very reasonable.